a senior product manager. I'm a senior product manager with the Prisma SDWAN team. And I'm going to kick this off by just giving a brief introduction and some context on some of the fundamentals of our Prisma SDWAN solution, especially around APIs and SDKs and how you can leverage APIs and automation to expand and operate your system at scale. So let's first start by discussing what it really means to have an API-driven network. So, we're seeing a lot of our customers are actually transforming their networks, and they're moving towards like cloud-based delivery of apps and, cloud-first strategy. So essentially this migration and this transformation can definitely benefit from automation and from APIs in several aspects. So first of all, by leveraging API-driven automation, you can actually streamline the deployment operations, and this helps you deploy sites in minutes versus days or weeks. So you can automate the whole process around like basically onboarding, configuration, and so on. And this helps you actually essentially deploy a large SD-WAN network in a matter of days. The second area is automating integration. So as part of Prisma SD-WAN, we have the CloudBlades platform, and we're going to be talking about that extensively today, which essentially provides pre-built third-party API integration to instantly enable third-party cloud services at your branch and at your data center. So that's like a second aspect of the API-driven network. And then the third aspect is automating operations. So automating things like trouble ticket triage, enabling help desk support to do more using machine learning, chat bots and chat operations, and also AI ops. So essentially, these are three areas where APIs and automation can actually help in your journey towards like a cloud delivered branch and leveraging like cloud apps. Now, before I get into details about some of these aspects, let's level set a little bit on some of the I guess fundamental differences as an enterprise journey is moving towards the cloud, and what does it really mean to migrate from an enterprise app model towards more like a cloud app model. Traditionally, in enterprise networks, the transport is reliable. So, you can assume that you typically have like a 5.9 availability in terms of network availability. And then you're actually accessing your apps and you're delivering your apps to your workforce, through your data center and through your own network. But, this creates some challenges and dependencies on IT administrators and dependencies on the enterprise being able to provide availability of those apps. So in reality, you don't get the same level of availability in terms of application delivery. Now, when you're transitioning towards like a cloud app model and moving your apps to the cloud, you can argue that cloud networks are really reliable. You'll get like a 5.9 availability in terms of application delivery, and at the same time, you're going to be leveraging, instead of using like a private WAN or an MPLS, you're going to be leveraging broadband internet or even like a cellular transport or a mobile device. But this, at the same time, will actually reduce your network uptime and your network availability. You're going to have cases where you have some congestion. You're using like a public Wi-Fi network and things like that, right? So that's going to impact your network availability. Now, let's see how Prisma SD-WAN can actually help address some of these challenges, right? So Prisma SD-WAN allows enterprises to deploy low-cost transport. So it enables you to use broadband internet, to have direct internet access, use cellular transport for accessing your cloud-hosted apps. And then, at the same time, by taking advantage of some of our capabilities like advanced link monitoring, app reachability, failure detection, and so on, SD-WAN can actually bridge that gap and provide highly available network and application uptime at the same time. So, at the end, the benefit of running a, Prisma SD-WAN network on top of your underlay network enables you to get good performance on your applications, but at the same time having a reliable network connectivity. Now let's talk a little bit about some of the challenges that you can have in an enterprise, regardless of size, right? So and how Prisma SD-WAN has been designed to essentially expect the unexpected, right? Being able to protect against situations where you have an unreliable network, but also being able to address cases and essentially leverage DevOps to avoid situations where you have what we call an unreliable administrator. So I'm going to talk a little bit more about these two examples. So what do we mean by unreliable network in this case, right? So traditionally, enterprises have been using MPLS WAN circuits or leased lines to have a reliable network infrastructure. However, these services are costly and typically offer you lower bandwidth. Now, with Prisma SD-WAN, you can actually take advantage of a lower cost direct internet access by using broadband internet, which typically would be consumer grade internet. But those networks can be inherently less reliable. Primarily, not that you won't get the high bandwidth and the high speeds, but a lot of times you're going to face some congestion issues. You may have some temporary outages and things like that you have to worry about. The other thing is that enterprises can now use cellular 4G, LTE networks, and also 5G. And with Prisma SD-WAN, you can use some of our appliances to leverage a cellular transport, either for a primary connection in locations where your branch does not have access to a traditional circuit, or as a backup circuit to your main connectivity. With Prisma SD-WAN's advanced path monitoring and application performance monitoring, which is based on layer 3 all the way to layer 7 attributes, and then with robust path selection, as we discussed in previous webinars, the solution ensures that traffic will always be on the best performing path. So these are some of the things that addressed in terms of network. Now let's look at the scenario of what we call an unreliable administrator, right? And we here, I think in this example, the main thing we want to highlight is that in most cases you're going to have a very competent and talented administrator, but at the same time, that person or that team would typically be extremely oversubscribed, having to handle a lot of other tasks on a daily basis, right? And a lot of times those teams are operating in a constant troubleshooting and maintenance cycle mode, and don't really have the time and the bandwidth to document changes in the network. A lot of times they'll just have to address a high priority ticket, and they won't have the time or the process in place to make sure that this is properly documented so it doesn't happen in the future. And then you have situations when you're going to type the wrong character, you're going to fat finger some information, and this can create some issues in your configuration or in your network that you have to address, right? So what we'd like to focus on today is how you can avoid some of these challenges of network availability and also administrator bandwidth and time by leveraging automation, by leveraging DevOps to simplify and streamline some of these operations and be able to scale your network without having these challenges. So as a first topic here, I'm going to talk about our CloudBlades platform. So CloudBlades is a part of Prisma SD-WAN, and it's provided as part of our solution at no additional cost. It can be enabled at tenant level. And what it does, essentially, it's a platform that enables seamless integration of branch and cloud-based services without actually needing to update your branch appliances or controllers, which helps eliminate service disruptions and complexity. CloudBlades is essentially like an extensible API-based platform, which automates deployments of third-party services, things like collaboration services, security, multi-cloud deployments, operations, and also WAN, and helps expedite deployments. At the same time, CloudBlades platform also enables the seamless deployment of Prisma SD-WAN virtual appliances within specific environments. So in essence, it helps simplify network operations and integrate services at the branch in a very streamlined way, as we will explain with some examples. I'm going to start first by going over CloudBlades for operations and collaboration services. Over the course of the last year, we've actually released a number of different CloudBlades across the different types of services that I explained. Specifically on collaboration and operations, we have released in the last 12 to 18 months a ServiceNow CloudBlade, Microsoft Teams ChatOps CloudBlade, and most recently Slack ChatOps CloudBlade. The ServiceNow CloudBlade helps with automated incident ticket creation and management, and AIOps event correlation for optimized incident reporting. On the collaboration CloudBlades, we have Microsoft Teams and Slack. Essentially, these are ChatOps CloudBlades that help with provide granular user control for chatbots, and also a simplified user experience using text-based queries and requests. And we're going to give some example about those in the upcoming slides. So let's first start with ServiceNow, which is our one of our operations CloudBlades. Let's first talk about some of the integration benefits with ServiceNow. So if as a customer you actually are using this CloudBlade and you also have access to a ServiceNow license, what you can do is actually you can support real-time incident management by automatically creating tickets based on Prisma SD-WAN's events, assigning the right severity level, and providing incident details. At the same time, you can also configure email and text-based notifications to be sent to your end users, which helps reduce time to troubleshooting and resolution. The end result is that you actually get fewer trouble tickets, which helps your IT team to focus on the real root cause of the incident by leveraging things like event correlation and AIOps, which is built in the SD-WAN platform. So by integrating with ServiceNow, you leverage these capabilities end-to-end in your ticket management system. Let's give some examples here. In this particular example, you have a number of branches and data centers in your network on the left. Those are all cloud managed through the Prisma SD-WAN controller. So every time you have actually an event, by leveraging the ServiceNow integration CloudBlade, this event will be converted into an incident ticket. And then the ServiceNow incident management platform will be able to forward these tickets to your IT help desk for monitoring. We'll be able to generate notifications by email or to a mobile device. And we'll also be able to communicate, and help troubleshoot and resolve the ticket. So it's a two-way communication. So this is kind of a summary of the benefits with ServiceNow. Let's now talk a little bit about some of our collaboration CloudBlades, and specifically some of our ChatOps capabilities. So the benefits of these CloudBlades is that they give you real-time access to the network and application performance metrics. So in a way, you can have like natural language-based queries, from your Slack interface or from your MS Teams interface to actually query your SD-WAN network and get information about, like, what type of, look at your sites across your network, and then get specific details about the site and so on. Everything, all the access is secure. It's role-based access control, and you can actually get network information and network stars from any location by using the same role-based access control that you have for accessing your SD-WAN controller. So let's give some examples here on specifically for Microsoft Teams CloudBlade. We'll show here, like, okay, a few screenshots. So first of all, if you type help, you'll just see here on your screen some of the options that CloudBlade you will provide, right? So the next thing is I'm going to type, show sites, and I'm going to be able to see here a number of my sites, the state of each site. In this particular case, most of them are active. You'll see what tags are configured on these sites, the type of site, whether it's a hub or a spoke, and then the domain. And then if I pick one specific site, in this particular case, let's take Dale Hollow, and I type show help Dale Hollow, I'm able to see some more details about that site. I can see how many ions are available or allocated, assigned to that site. I can see, events, circuits, VPNs, and so on. So I can see the status of different attributes for that specific site. These are some of the key queries, right? So help will give you actually a list of options. Show sites will give you the site names, the state, the tags, the type of the site, and then the domain. Then, if I type show sites and the specific site name, I'm able to actually see different attributes for that site, and then their associated configure values or current values. And then here's another example of another command. So if I do a show help, and I'm kind of having the same example as I had on my first screen for a specific site, I can see here, like, number of ions, number of events, number of circuits, number of VPNs, and specific information on those VPNs in terms of endpoints. And then the status in this particular case of a branch site to one of my cloud delivered security endpoints. So these are some of the examples, and typically, this is like a simple way for your admin to look at, device connectivity status, quickly check the count of open, critical, and major alarms, event counts, circuit and VPN status. Now, here's the last example I'm going to show here for collaboration apps. So, show apps specifically for your tenant will give you the number of apps that are available. And you can see there's a column that shows you the app type. So you can see which app is a system app and what app is a custom app, right? So you have here Amazon.com created as a custom app in your tenant. And then if you want to focus on a specific app, you can type show apps RTP, for example, and you can, here see specifically for RTP specific attributes, like, for example, the ID, display name, abbreviation, domains, TCP rules, UDP rules, and so on, right? So this is an example of how you can actually look at all the attributes of a custom or a system app, and you can quickly query those through through your Microsoft Teams app without really having to log into the SD-WAN controller UI and pull that information from the UI screen. So this is like a number of examples on how Prisma SD-WAN actually leverages collaboration and operations CloudBlades to provide that capability. So with that, I'm going to hand it over now to Richard, who is going to talk about CloudBlades for cloud service providers.
Thanks, Hazel. Okay. Yeah. So, as Hazel talked about, we have CloudBlades for operations and chatbots, but we also have CloudBlades for other functions as well. So we're going to focus on the CloudBlades for service providers first. So, there are certain challenges that come with moving to the cloud. So if we just talk about accessing the cloud with a traditional kind of WAN network. So normally your branches are not going to have direct connectivity from every branch to the cloud service provider. Doing that is quite operational overhead to manage all of the connectivity. So typically traffic is going to be backhauled from a branch location over, let's say, an MPLS to a data center, and then from that data center is going to have a connection into the cloud service provider. So this doesn't always provide the best user experience. It's taking multiple hops to get there. It has to go via a data center that may not be within region to a cloud service provider that is in another region as well, and all this latency can, it can diminish the user experience from accessing it. And then also moving to the cloud, it requires a different skill set. So, your traditional people that manage your WAN networks, they may be good on the CLI routing and switching kind of stuff, but moving to WAN networking, it's a slightly different mentality. It requires a new skill set in order to be able to manage all of this. And then, as we grow in the cloud, we have, what we call the VPC sprawl, and VPC is kind of an AWS term, but just meaning that the networks and the applications that we have in the cloud are, starting to grow exponentially, and how we manage all of the access to these different VPCs can become a challenge. So the idea of the cloud service provider CloudBlades is to simplify your connectivity from your branches to the cloud service providers. So what we're doing is we're extending the SD-WAN essentially to the cloud. So we're going to use our automation platform within the CloudBlades platform to automatically deploy Prisma SD-WAN devices in the cloud service providers. And along with just deploying the virtual appliances in the different cloud service providers, we're going to build the connectivity to those applications and those services that live within each of the clouds as well. So we're doing the kind of full end-to-end cycle of deploying the connectivity to the cloud and then connectivity within the cloud as well. And you'll see in a second the different examples, but we support the three main cloud service providers with our CloudBlades platform. So we have support for AWS, for Azure, and for GCP. And we've kind of normalized the deployments across these providers, meaning that the way in which we deploy into each of them, from an SD-WAN user perspective, from actually deploying with a CloudBlade, it looks the same. There are nuances per provider as to how it's implemented, but we extract that kind of complication away from you and making it much simpler for you to connect to one or many regions within each of the cloud service providers that you're utilizing. And then once these appliances are built in the different service providers, as with a normal SD-WAN data center device, your branches will automatically build connectivity to each of these service providers, meaning that you don't have to go to each branch and touch them in order to stand up connectivity to each of your AWS regions or your Azure regions. The SD-WAN branch devices will automatically build VPNs to each of these cloud service providers and each of the regions into which you've deployed into. So the CloudBlades leverages our Prisma SD-WAN virtual ION form factor. So you may or may not be familiar with it. We have traditional physical appliances for the SD-WAN platform. They're based on the bandwidth requirements that you need for each one. And then we have a variety of virtual appliances as well. So these can be deployed in a physical, so they could be deployed in a branch. They could be deployed in a data center on something like ESXi or KVM. And then they can also be deployed in public cloud as well. So we have marketplace listings for AWS, for GCP, for Azure. We also have a marketplace listing for OCI as well. And, and we're working on supporting other cloud providers as well. So they give you the full suite of SD-WAN performance and features that you're used to with the physical appliances, but just running in a virtual form factor as well. So they do support HA as well in the data center deployment, and depending on the model that you're using, and specifically talking with the cloud service providers, we're looking at around 3.5 gigs of encrypted throughput per virtual appliance that is deployed in a SD-WAN data center. So if you have an HA pair of virtual ions in a region in AWS or Azure, you're going to get 7 gigs of aggregate throughput for that virtual data center in AWS or Azure. Okay, so this is what the multi-cloud connectivity model looks like. So on the left-hand side here, we have your traditional SD-WAN branches with the SD-WAN ion appliances in them. And then on the right-hand side here, we have each of our CloudBlades and how they would be deployed in each of the cloud service providers. So the top one here, we have AWS. So we have a virtual ion that is in a transit VPC. And for each of these examples, there was actually a pair of HA ions deployed. We just kept it simple with one for the diagram. But these virtual ions are deployed in different availability zones within AWS for higher redundancy. And connectivity to your host VPCs, where your applications live, is provided through a transit gateway. So the CloudBlade will deploy the virtual ions, and then it will automatically build a VPC connection to your transit gateway. Then it will build a VPC Connect attachment on top of that, and that will allow us to exchange routing information between the AWS networking infrastructure and the SD-WAN environment. And then similarly for GCP, in GCP, we leverage something called the NCC, which is a Network Connectivity Center. And this allows GCP regions to exchange routing information between them. So a very similar model here. We have an SD-WAN transit VPC with a pair of virtual ions deployed in different availability zones. They have connectivity to their local in-region GCP cloud router. And then the cloud router is connected into their NCC hub in order to do multi-region connectivity. And then your local host VPCs per region would also be VPC peered into the same cloud router. And that, again, provides connectivity from the SD-WAN world into your GCP host VPC networking. And then finally for Azure, very similar again, we're deploying a pair of HA ions into a transit VNet in this case, and we're leveraging Azure Virtual WAN. So the automation will deploy 2 virtual ions in a transit VNet. This transit VNet is a spoke VNet, which is attached to a vWAN hub. And that vWAN hub then has attachments to the host VNets within the region. And then if you have a multi-region deployment with multiple vWAN hubs, we can deploy SD-WAN transit VNets in each region as well to provide full connectivity to each of your regions. So as you can see, the technology that each of these cloud providers uses is slightly different. So transit gateway versus NCC versus Azure vWAN. But we can build connectivity to all of these, and the actual configuration of the connectivity between the two is automated through the CloudBlade. So if we just look at a workflow for AWS, the workflow is going to be similar for the other providers, just based on whatever connectivity method we're using. So the first one is to deploy the ions. So we're going to build a VPC, a transit VPC within AWS, and then we're going to take the 2 ions and we're going to deploy the ions into that transit VPC. They'll have different connections for WAN facing and core facing, and we'll assign the appropriate subnets within that VPC to it. We'll then deploy the ions and configure the appropriate IP addressing, and then we'll take the transit gateway information, which is input into the CloudBlade as part of the configuration, and do the attachments to that transit gateway. So we do a traditional VPC attachment from the SD-WAN transit VPC to the transit gateway, and then on top of that, we build a VPC Connect peering. This VPC Connect peering allows us to exchange routing information over a GRE tunnel between the ions and the transit gateway. And then once everything is deployed, all of the branches will then build SD-WAN connectivity to the virtual appliances, VPNs will be established, and then you can build your appropriate path policy in order to send traffic to the AWS DC. Okay, so we're going to switch gears a little bit and talk about automation and SDK use cases. If we just look at some of the examples here, these are real customer use cases that have used our SDK and automation to deploy at speed and at scale. So example here, Food City, 47 sites in 48 hours. Aaron's, here we've got 70 sites a week for 2,000 stores in total. And then Chipotle, your favorite burrito vendor, deployed nearly 3,000 stores in 8 months. And just to note, this Chipotle deployment was done during the height of the pandemic, when things were on lockdown. And even with all of that going on, leveraging our automation, we were able to roll out a full SD-WAN deployment in a very short period of time. For the Chipotle use case specifically, there was really very little on-site work that was needed to be done by any of the Chipotle team. Essentially, everything was pre-staged, shipped to a site. All the pre-staging was done using our automation, and then essentially the box was just plugged in, and the site was transformed to SD-WAN, within an hour or two. So there are different use cases for automation. So we're just going to kind of run through a few different use cases here. The one is multi-site deployment, and that's kind of what I talked about in the previous examples with some of the use cases. So this is where a team of deployment engineers can leverage automation to deploy multiple sites at the same time, leveraging the automation. So rather than having to touch each site individually, bring the box online, go into the UI, configure the interfaces, the circuit labels, routing, etc., we can leverage automation to push configurations to the SD-WAN controller. The SD-WAN controller will then automatically push those configurations to each of the devices. And instead of going from, let's say, 30 minutes of configuration to deploy a single ION, you could push the configuration for 10 sites in less than 5 minutes. And so that's the kind of day one deployment. And then we have day two use cases as well. So in this case here, we've got a corporate DNS update that needs to happen. So our DNS servers have changed, and we need to update all of our devices. If you have a handful of devices, it's not a big problem to go do it manually. But if you have a large network with thousands of SD-WAN devices, trying to do that is a monumental task. It would take many weeks, perhaps, to go and touch them all individually. So by using automation, we can push out the DNS updates via the API to the SD-WAN controller. The SD-WAN controller will then automatically push those out to each of the SD-WAN branch devices. And then likewise, if you have a failure of a branch and we need to issue a replacement, if you look at the typical method of replacing a router or a switch, right? You have to get the hardware, you have to get it to site. Somebody has to connect a console to it, perhaps. Then they have to put in some rudimentary configuration, and then maybe configure it by hand as well. So in this case, it's much simpler than that. We can take an existing configuration of the device that failed. We can just update the serial number in the configuration. We can re-push that configuration to the controller, and then the site will be redeployed automatically. All that needs to happen is that the device, when it's sent to site, is just plugged into an internet connection, so it can talk to the cloud controller. At that point, nobody has to do any manual configuration. Nobody has to get onto a console, find a console cable. It greatly simplifies the replacement of a new device. And then also, keeping stuff in specification. So, your enterprise may have certain requirements for, let's say, policies or interface configurations, and we want to make sure that everything is within specification. And it will happen that things do get changed. Maybe something was changed during a troubleshooting and it needed to be changed back, but the person that was doing it forgot. So we can use automation to keep track of what our configurations should look like, and then compare that to what they actually do look like. If the configurations are out of spec, we can have some mechanism that can flag that out of specification device, and then we can just repush the golden configuration to the devices that are out of spec, and then they are now back within specification. So those are the kind of few different use cases, and the ultimate goal is network as code. This may be not that something for everybody, but for those that are interested in going down the automation journey, then the end goal is network as code, right? So that we are not going to the devices and configuring them in the UI manually. We're using a kind of code-driven repository that houses all of our configurations, and then leveraging things like templating, our RESTful API interface, the zero-touch provisioning, the cloud controller. We can use all of this to maintain our configuration as code instead of the configuration living in the master configuration living in the cloud controller. So this enables a few different things. This enables mass changes. The example I gave previously was DNS updates. So this kind of network as code allows us to modify the configuration of all of the devices within our repository to the new DNS entries, and then push those out in a matter of minutes. Okay, so if we just look at an example of how does Prisma SD-WAN deployment automation work, or Prisma SASE deployment automation work. So there are a few different components to the automation. The primary one is our CloudGenix config utility. So this is a tool provided by Palo Alto. It's still got the old name CloudGenix, but it's up to date and is fully supported by Palo Alto. And this is a Python-based tool that allows for import and exporting of configurations from the cloud controller. So you have a branch device and we need to bring it online. We can use the CloudGenix config utility to push a configuration to the cloud controller to onboard that device automatically. And likewise, if we want to extract the configurations from an already configured device, we can use the config utility to pull that configuration down. If we need to make changes to it, we can make the appropriate changes to the configuration file, and then we can re-push the configuration back to the controller to do the appropriate updates to the device. So this config utility, it can be used as kind of a manual push and pull, or it can be integrated into a CI/CD continuous integration, continuous deployment tool if used in a kind of network as code DevOps environment. So when we talk about the configuration format that is used by these tools, so we leverage something called YAML. So YAML is a kind of human-friendly data serialization language, and there's an example here on the screen. So this is an example of an SD-WAN device's configuration. It's just a snippet of it. Depending on what you have configured, there will be a number of sections to this YAML file. But here you can see this is the name of the site here, Rich Home 1K. You can see here this is the address information, and then you can see this is the host name down here. All of the configuration for the device can be contained in one YAML file. And if I want to make a configuration change, I have two options to do it. I can do it by the UI, or I can do it using the YAML files by modifying the configuration and then re-pushing this configuration back up to the controller. And then when we talk about automation, one thing that we leverage with SD-WAN automation is using templates. So we'll have a template for a particular site type. So let's say it may be an ION 2K HA site. So we'll use something called a Jinja template. And if you look at the format for the Jinja template, it's very similar to what we showed for the YAML file. So you can see it's the same structured format. But in these Jinja templates, we can leverage these variables. So here we have the site name, we have the address variables here, and then we have the host name. So this matches back to the previous example that we showed. And we can take these Jinja templates and then we can put them together with some kind of source data. The source data could be one of many different things. I've got a very simple example here. We're using the same example as before. We have a CSV file that contains all of my site data. And I could have multiple rows within this CSV file that have all of my site configurations in it. But it doesn't have to be a CSV file. CSV is the simplest way to do it. It could be an IPAM tool, CMDP, GitHub repository. It could be one of those or multiple of those together, where we stitch all of the data sources together. And then we'll take the Jinja template that we have here, and we'll take the corresponding data, the site and device data that we have, and we'll put those two things together in order to build our site configurations. So, I can take all of this data, I can have a spreadsheet with 100 sites in it, and I could build all those configurations, very quickly with a very kind of rudimentary Python script that would then give me 100 site configurations that I could then take to go and rapidly deploy using the CloudGenix config utility. So if we just look at an automation workflow. So we have the site and device templates. Those are the Jinja templates that I just showed. And then we'll have some kind of site and device data. So what we're going to do is we're going to take those two items, the device template and the site data, and then in this example, we have a SD-WAN config Python file, which essentially passes the data from the CSV file and then uses the templating language to build corresponding YAML files. So from that, we're going to get 1, 2, 3, 100 YAML files. And then using the CloudGenix config do-site utility, so the do-site portion of the CloudGenix config tool is the one that allows us to push the controller. We're then going to push these configurations to the cloud controller. The cloud controller is then going to take all of those configurations and then push those out to the end devices, rapidly onboarding all of the SD-WAN branches. Okay, so just a quick call to action before we finish. There's some links in here which link to our Python SDK, to our CloudGenix config tool, our SD-WAN API reference guide. We also have a getting started SDK guide on our website as well. And there's a link here to GitHub repo, which has some SD-WAN automation scripts that you can leverage to do kind of the DevOps style deployments. Okay, and that's all I have for today. So thank you very much.